probability. And I am Teacher Burns. We have Module 3, Random Sampling and Sampling Distribution, Lesson 3, Sampling Distribution of the Sample Means from a Finite Population. After this video, you should be able to identify sampling distributions of a statistic or sample mean, construct a sampling distribution, and graph the sampling distribution in a given problem. Do you remember this expression from your previous mathematics lesson? This is factorial, read as 3 factorial. This means that we multiply the given number in descending order until the first counting number, which is 1. Thus, 3 factorial is equal to 3 times 2 times 1 equals 6. Another expression is 5 factorial divided by 3 factorial. First is we expand the numerator, so we have 5 times 4 times 3 times 2 times 1. And expand the denominator, which is 3 times 2 times 1. Then we get the product of the numerator and divide it to the product of the denominator. So the answer is 20. Or, after we expand the numerator and denominator, we take a look at the common factors. This happens to be 3 times 2 times 1, which is considered common between the numerator and denominator. We apply cancellation. After we cancel them out, what is left in the numerator is 5 times 4, and in the denominator, we have 1. Therefore, 20 divided by 1 is 20. So we have the same answer but different way of solving. You may use any method convenient for you. Now, a sampling distribution of the sample means is actually a probability distribution where all possible random samples of a specific size were taken from a population. We have here finite population. Finite has a fixed number of elements or observations. For example, 3, 6, 7, 12, and 4. We construct a sampling distribution of size 3 from this finite population in order to create random samples. We use this formula where the upper key n is equal to the number of observations, while the lower key n is the size of possible random samples. So this is our solution. First is we count the number of observations. So we have 1, 2, 3, 4, 5. We use this as our given in order to solve. Now let us have size of the possible random sample, which is 3. Using upper key n equals 5 and lower key n equals 3, we substitute it to the given formula. So we have 5 factorial over 5 minus 3 factorial times 3 factorial. So the answer is equal to 10. So we have the formula, the given, and the solution. The answer is 10. But the question is, how did we do that? So this is the solution. We expand the numerator, so we have 5 times 4 times 3 times 2 times 1. And we expand the denominator. So 2 factorial becomes 2 times 1, while 3 factorial becomes 3 times 2 times 1. Multiplying the numerators, we have 120 as the product, and multiplying the denominators, the resulting answer is 2 times 6. Multiplying 2 times 6 is 12, and dividing the numerator by the denominator, the final answer is 10. This is our alternative solution. After we expand the numerator and the denominator, we check for the common factors. Cancel out the common factors, so what is left is 5 times 4, which is 20, and 2 times 1, which is 2. Dividing 20 by 2, the answer is 10. You can use any method convenient for you. So 10 is the random samples of size 3 that we shall be creating. So again, from the finite population, we make a sampling distribution of the random samples, and this is our distribution. random samples of size 3 from the given finite population. So we just combine any three of the following numbers. So you have 3, 4, and 6, 3, 4, and 7, 3, 4, and 12, 3, 6, and 7, 3, 6, and 12, 3, 7, and 12, 4, 6, and 7, 4, 6, and 12, 4, 7, and 12, and 6, 7, and 12. Notice that there are 10 random samples of size 3. Next is to get the sample mean. We will take the mean of each of these samples. So, starting from the first one, we have 3 plus 4 plus 6 divided by 3. The answer is 4.33. Then, the second is adding 3, 4, and 7 divided by 3. The sample mean is 4.67. Followed by the third, which is 3, 4, and 12 divided by 3. The sample mean is 6.33. Then we have 3 plus 6 plus 7 divided by 3 gives us a sample mean of 5.33. We continue doing it until the last random samples of size 3. So we have 6, 7, and 12 divided by 3. The answer is 8.33. Now, the next step is to construct a frequency distribution of the sample means. This is called the sampling distribution of the sample means. We only take the sample mean. Then, we make a frequency distribution. First is let us arrange the sample means from the lowest to the highest with no repetition. So, we inspect each of this and make a frequency, which means the number of times that it occurs. So, first is 4.33. There's only one 4.33 here, so we put 1 as our frequency. Next is 4.67. There's no other 4.67, so still we put 1 as our frequency. Then 6.33. There's also one 6.33, followed by 5.33, and then 7, then 5.67. Each of these has one frequency, but 7.33, there are two 7.33 in our sample mean. So we put 2 in our frequency, then followed by 7.67, which is 1, and 8.33, which appears only once, so our frequency is 1. After that is we get the sum of the frequencies, and the total is 10. Remember, 10 is the answer after we use the formula to identify the number of random samples of size 3. Next is how do we solve for the probability? We use the formula probability is equal to frequency divided by total. The first frequency is 1 divided by the total of 10, so our first probability is 0.10, followed by 1 divided by 10 gives us the same probability of 0.10. We continue doing so until the last part. Now, notice here that our frequency is 2. We divide it by 10, so our probability is 0.20. Our probability is 0.2. Then followed by 1 divided by 10, and the last one divided by 10. Now, if we get the sum of all the probabilities, the answer is 1. How do we know that our solution is correct? That is, if the sum of all the probabilities in here is equal to 1. The total probability is always equal to 1. We have to take note of that. Now, the third step is graph a frequency polygon or histogram. We only need the column for sample means and probability in here. So this is how our polygon or histogram look like. At the bottom of the graph, we put the sample means and we follow the arrangement, which is descending order. So 4.33 until the last or the highest value of 8.33 is placed horizontally or at the bottom of the graph. While in the vertical side is the probability. So we start from 0 and then 0.05 followed by 0.10 and 0.15, 0.20 and 0.25. Now, how do we put the graph? So we look at sample means and its corresponding probability. Starting from the first one is 4.33 and its probability is 0.10. So we stop at 0.10. Now, if you look at all the sample means and the probabilities, we have the same probability until 7, or sample means 7. So from 4.33 until 7, we stop until 0.10. But in 7.33, our probability is 0.20. So that is why 7.33 stops at 0.2, while the rest of the other two sample means stop at 0.10, because that is their probability. So this is how you create a polygon or histogram. I hope you understand the process. Now try this. Activity 2. You list and construct. A group of students got the following scores in an achievement test: 9, 12, 15, 18, 21, and 24. Construct random samples of size 3 that can be drawn from this population. For the solution, please refer to your Statistics and Probability Module 3. Take note that the population is 6 and you are to construct random samples of size 3. So what have I learned? I learned that a sampling distribution of sample means is telling us about the probability distribution where all the possible random samples of specific size were taken from a population. Now, what can you say about the sum of all the probabilities in a sampling distribution? What is the thing that we have to take note after getting all the probability from the sampling distribution? Alright, so the sum of all the probabilities is always equal to 1. So bear that in mind. What's the probability of living the best life? Regardless of its probabilities, we only have one life to live, so live life at its best. It's not a chance, but it is a choice. Godspeed! I hope you're enlightened. That's all for now. See you next topic. Please hit like, click subscribe, and please share. Thanks for your time. God bless.